Math 193 in class activity 2, the sine and cosine functions. In the diagram shown, t is the measure of the indicated angle, and d is the vertical distance from the point on the circle to the horizontal axis. Suppose that t is increasing at a constant rate, so that the point is moving counterclockwise around the circle. Describe how the distance d changes. Does it change at a constant rate? If not, when is it changing the fastest? I want you to pause the video, think about this question, and attempt it, and we will take it together. Answers to this question are going to vary, and this is a sample answer. D changes according to a sinusoidal function. It does not change at a constant rate. It is changing the fastest when t is equal to 0. And when t is equal to pi radians, it increases until pi on 2, and then radians, and then starts to decrease as you can see in the diagram. Objectives for the activity. You will understand that the sine and cosine functions can be computed using the unit circle. The sine and cosine functions are sinusoidal functions. You will be able to compute some important values of the sine and cosine functions using the unit circle. You will be able to evaluate and graph the sine and cosine functions using a graphing calculator or app using radians appropriately. Interpret formulas for sinusoidal functions in the context of a model. So far, we have seen several examples and applications of sinusoidal functions, but we do not yet have a way to represent these functions in formulas. In class activities 2A, we saw how the vertical and horizontal positions of points on a circle can be viewed as sinusoidal functions. If a circle has radius 1 and is centered at the origin, it is called a unit circle. And these functions are called the sine and cosine functions, denoted by sine and cos. The numbers cos t and sine t are the x and y coordinates of the point on the unit circle, corresponding to the angle t as shown in the figure. Now, if a unit circle has a radius 1, then applying the general formula for a circle, we are going to get something like x squared plus y squared equals r squared. And so when r is 1, we are going to get x squared plus y squared equals 1. Using cos t and sine t for x and y, this becomes cos squared t plus sine squared t is equal to 1, which is a very important identity in trig. And so every point along the unit circle should satisfy this expression. And so, for example, if we have cos t to be square root of 2 over 2 and sine t is square root of 2 over 2, then when we plug these into that expression for the unit circle, we should get 1. Part A, use the given figure to complete the table of values. I want you to pause this video and complete this assignment, and then we will look at it together. Now, looking at the question, if we are saying that at this point, if we have this angle, then the value is cos t sine t. Let's draw a right triangle with a radius 1. Then sine theta is equal to the opposite over the opposite divided by the hypotenuse. Now you will see that the opposite here is equal to our y, and the hypotenuse is our y, our r, which is 1. And so sine theta becomes y over 1. This means that y is equal to sine theta. And that is why we have the y coordinate to be sine t. Now by similar reasoning, we will get x to be equal to cos t. And so when we come to 0 degrees here, the value of the angle is going to be cos 0 and sine 0. And that cos 0 is going to give us 1 because we have only the x value. This is our x and that is our y. And then our sine 0 is going to be 0. At pi on 2, we have the values there to be cos pi on 2 and sine pi on 2. Now the cos is representing our x value and the sine is representing our y value. You realize that pi on 2, we are wholly on the y-axis. And so x is 0, and that gives us cos pi on 2 to be 0. And because we are lying on the y-axis, and this is just like the radius, which is 1, we have sine pi on 2 to be 1. And when we go to 180, we will see that the sine cos 180, because it's lying exactly on the negative region, our x is going to be negative 1, so cos 180 is going to be negative 1, as you can see. And sine 180, there's no y value here, exactly on the x-axis, it's going to be 0. Now when we come to 270, we are lying in the negative region, the y-axis, negative y. This radius is 1, there is no x here, so the cosine of 3 pi on 2 or 270 is going to be 0. And then the sine, we are in the negative region, the radius is 1, the sine of 3 pi on 2 is going to be negative 1. Now for 2 pi or 360, we have gone once round the circle and now we come to the 0 position. And so at that point, we are going to get the same value as cos 0 and sine 0, and that is 1 and 0 as shown. Part B, plot the graphs of the functions sine t and cos t on the axis, where t is measured in radians. Start by plotting the points given in the table you completed in Part A. Then draw the sinusoidal curves through these points. I have the table here for you. I want you to pause the video and try your hands at it, and we'll look at the solution together. Now, when we are plotting, you will see that at 0, if we take the sine first, at 0, sine 0 is 0, so we are at the origin. Sine 0 is 0. Sorry, sine 0 is 0, so we are at the origin. And when we move to 90 degrees or pi on 2, the sine of pi on 2 gives us 1, and so that is the point. And so we draw a smooth curve through these points to get our sine curve. Now we do the same. Cosine of 0 is 1, so we are starting here, and we draw a smooth curve through them to show the sinusoid for the cosine function. How could you use the unit circle to determine the sine and cosine of 3 pi radians? I want you to pause the video and try your hands at it, and we will come out with the answer together. Now, you can see that when we go once round this circle, we have 360 degrees or 2 pi. From here to the top is pi on 2. And then from here to there is another pi on 2. So from the 2 pi, if we added another pi, we are going to get our 3 pi somewhere here. All right. And 3 pi, we are at the point where we also had pi or 180 degrees. And sine pi was 0. And so sine of 3 pi is going to give it the same value as some pi, which is 0 degrees or 0. What are the periods of sine of the sine functions of the function sine t and cosine t when t is measured in radians? I want you to pause this video, think about this question, make an attempt, and we will discuss it together. Now, the period of the cosine and sine functions is 2 pi. And the reason being that after 2 pi, the sine function would have completed a revolution and it begins another revolution. And to find this from the graph, you will see that it is the part that the curve begins to repeat itself, begins to get the same pattern. And so if you look here for the sine, it starts this pattern from here, and then it begins to repeat that pattern at 2 pi. If you look at the cosine, this is where the pattern begins. And then after 2 pi, the same pattern repeats itself. And so I'm saying that the distance between the repetitions of any function is called the period of the function. The period of the sine or cosine function is 2 pi, which means that the value of the function is the same every 2 pi units. What is the phase shift in radians between the functions sine t and cosine t? Think about this and pause the video. After that, we'll take the answer. See if you can get the answer, and then we'll take the answer together. When we move our sine or cosine function left or right along the x-axis, we are creating a horizontal shift or a horizontal translation. In trigonometry, this horizontal shift is commonly referred to as the phase shift. If you look at the cosine and sine wave, the cosine leads the sine by pi on 2 radians. For example, cosine of 0, if you look at the cosine of 0 is 1, while sine of 0 is 0. All right, and sine will reach a value of 1 until 1/4 of the cycle has occurred, which is at pi on 2. And so if I decide to draw this cosine graph here, I would have to put it somewhere there. And then the cosine pattern will begin to show. Okay. And you can see that the cosine function is leading the sine function by pi on 2, a shift of pi on 2 to the right. We can also say that the sine is lagging by pi on 2. Right. What are the amplitudes of the functions cos t and sin t? What are the equations of their midlines. I want you to pause the video again, think about the question, and let's discuss it together after you have come up with some solution. Now the amplitude of each function is 1, and their midlines is y equals 0. The amplitude is always the highest point from if the function is starting, you're graphing from 0, 0, then this is going to be your amplitude. All right. This is going to be your amplitude, and that is 1 for the sine function, and that is 1 for the cosine function. Sorry, 1 for the sine function and 1 for the cosine function as well. Now the midline, that is the middle line, is just going to pass through the y-axis at the point between the highest point you can get on the graph and the lowest point you can get on the graph. And the average of these two points is 1 plus minus 1 over 2. So this is going to be your midline. And 1 plus minus 1 is 0 over 2. And your midline is going to y equals 0. And so, for example, if you are getting something by some transformation, we are getting something that starts from here and goes up like that. All you need to do is look at the lowest point, look at the highest point, find the average of these 2 points, and the midline is going to be the line that passes through that average.